Today we're going to be naming aldehydes the IUPAC way. So the first step that we take in naming aldehydes is we're going to be looking for the longest parent chain that we can find. And a parent chain is always going to start with the carbon of the aldehyde, so of the CHO, right? And so that's this carbon, so we know we can number this one 1. And it's going to follow the longest way that it can possibly go. So for example, you wouldn't go there because that's a hydrogen. You'd go over here to the next carbon, so we know we can number that 2. The next two adjacent carbons, you can go this way and name this 3, or you can go this one, name this 3, and then you can go on to name one of these 4. And so we want to take the route where we can name 4 carbons, because that'll give us a longer parent chain. So in this case, we'd go 3, and it does not matter which one you pick. Say we pick this one, and you get 1, 2, 3, 4, and then that is our parent chain. So we know that 4, right, corresponds to butane. But since we're talking about naming aldehydes here, we're going to change butane into butanol with Al. Al, not Ol. Ol would correspond to alcohols, right? So Al for aldehydes. And if we just call this butanol, right, we're not taking into account these substituents. It'd just be 1, 2, 3, 4, and then that's it. And we would be ignoring this methyl and then that methyl. So we need to take into account the 2 methyl groups. And so to do that, we know that there's a methyl group at 2, and we also know there's a methyl group at 3. And so we can do 2, 3, and you'd separate words from numbers with a dash. So that's what I'm doing there. And we would say 2, 3, since there's 2 methyl groups, it's 2, 3 dimethyl, and then you can say butanol. And there we go. That's how you would name this kind of aldehyde. Another kind of aldehyde you might see is with a cyclohexane, for example. So in this case, here is our CHO group, and let's put a substituent over there. And so to name this one, first we look for the ring, and we're going to name the ring, and we know that this is, because it has 6, this is a cyclohexane, so you can say cyclohexane is going to be somewhere in the name, right? And then to take into account that this is an aldehyde, you have to add the word carbaldehyde. You must do this, carbaldehyde. Okay? So we know the end of our naming for this is going to be cyclohexane carbaldehyde. But what about this chain right here? You have to, this substituent, you have to take into account the substituent, or else we're just looking at this chain plus this CHO group. So to do this, we have to number it. So once again, we always start with this carbon that's part of this, that includes the CHO group. So this is going to be our number 1. We can make this number 2, 3, 4, 5, 6, but the rule in naming aldehydes is that we want to give our substituent the lowest number. So it's actually going to be 1, 2, 3, 4, 5, and 6. And so when we're naming this, we know that there's a 2, an ethyl group at the number 2. So we can say 2, and remember we separate word and number by a dash. 2 ethyl cyclohexane. If I could fit the rest of the word, carbaldehyde. And so that would be the correct naming for this. Okay, so let's do an example. This example is going to correspond more to the first problem type I talked about, and then we'll do one with a ring as well. So the first step, right, is to identify our parent chain, right? Parent chain. And this is going to be the longest, right? So, and you always start, number 1 is part of CHO, right? So it's going to be this carbon will always be our first carbon. And then we want to take the longest route. So 1, 2, we could go to 3 over here, but we don't want to because that's too short. 1, 2, 3, 4, 5, and we could do 6 over here, but we don't want to, right, because that's also too short. So we'll do 1, 2, 3, 4, 5, 6, 7, no, right, 7, and then 8. And 8 corresponds to what? It corresponds to octane. And what do we do with this? We turn octane into octanol with an AL. All right, but we do need to take into account all of the substituents, right? We have substituents here. We have a methyl group here, a methyl group here, and a methyl group here. And so what you can do is now you can name this as 2, 5, 6, because there is a methyl group at 2, 5, and 6, trimethyl. And then octanol. And that would be how you name this aldehyde. Okay, let's do one more example. Okay, so here's our last example, and this corresponds more to the second problem set because we're looking at a ring. So first, remember, we're going to name the ring. We have a cyclobutane, right? Butane corresponds to 4. And remember, we always have to add the carbaldehyde. So we know that this is going to end with cyclobutane carbaldehyde, but we need to number and identify these substituents, right? So I talked about how this carbon right here, connected to the CHO, always has to be our first carbon in the chain. So it would be 1, 2, 3, and as you can see, you go 1, 2, 3. Either way, that these two CLs are going to be at the third. So you would say, since we have 2 CLs, we'd have to do 3, 3. You always have to put an X. You can't just say 3 CL. You have to write a number for each one. And we always separate numbers and words with a dash. So 3, 3, and then we have 2, right? So dichloro. And then you would finish this off with cyclobutane carbaldehyde. So it's super long, but that would be the correct naming for that. So I hope that was helpful. If you have any questions or you have some weird examples that you want to show me, just leave them below, and I hope I can get back to you quickly. But if not, I hope you enjoyed that and that was a little bit helpful.